ambil exam online yang kena kuarantin ke, tak apa masalah internet ke tak cukup kuat. So kalau kamu ada masalah, kamu kena beritahu saya lah secepat mungkin lah. Dan satu lagi yang mana yang pakai CCMP Wind Speed Direction, okay, yang dah download untuk especially yang Wind Direction tu, you kena download semula sebab hari tu Wind Direction tu ada error calculation error, so saya dah betulkan balik. Yang dia punya speed tak ada masalah, okay, cuma masalah untuk Wind Direction. So mana-mana yang pakai yang download daripada MyElearn tu yang saya upload tu, you kena download balik, okay, untuk Wind Direction. Wind speed tak ada masalah. Dan saya dah uploadkan R script untuk nak interpolate data, especially yang pakai ocean color lah, Modis data, sebab dia ada banyak missing value. Okay, so the best way is to interpolate. So interpolation ni dia berbeza dengan interpolate yang you belajar dalam GIS. Okay, GIS tu dia cuma bergantung kepada satu source saja ataupun satu image saja. Okay, yang R script yang saya buat tu, dia akan analyze keseluruhan data tu. Okay, dia akan tengok trend. Okay, and then baru dia interpolate lah. Okay. So kalau you ada banyak data, okay, so dia punya interpolation in term of accuracy tu dia lagi tepat lah. Okay. Dia berbeza dengan you buat kriging dan sebagainya. Okay, that one is not accurate. Okay, that one is based on just one image or just one source of data. Okay. Tetapi interpolation yang kita bagi sebagai name of ni, okay, dia akan analyze. Okay, kalau you ada katakan 200 data, dia akan analyze 200 data and then dia akan tengok dia punya trend dia. Okay, sebab especially chlorophyll ni dia ada trend, dia ada yearly punya trend. Okay, so dia akan analyze dia punya trend and then baru dia guess. Okay, the missing values. So untuk final exam dan test, okay, review. So untuk test dia akan masuk daripada from lecture 0 to lecture 5, okay, from the intro to satellite oceanography, okay, until surface temperature. Okay. So yang radar, microwave tak masuk lah. Microwave ataupun radar, altimetry, okay, dia adalah topik 6 nanti. So kita tengok satu-satu So kalau you nak record lah. Okay, so lecture 0 So what's the important topic in lecture 0? Okay. The first one is the importance of satellite oceanography. Okay. Or the importance of satellite in oceanography. Okay, iaitu yang kamu kena tahu. Okay. So saya tak masuk kat sini. So, okay, dalam lecture note tu, saya bagi the importance of remote sensing or satellite, okay, in oceanography. Okay. So, what is a satellite oceanography? Apa yang dipanggil sebagai satellite oceanography? Okay. So, okay, semua orang tahu satellite oceanography, okay, is a study about the ocean condition and processes, okay, using remote sensing. That's a satellite oceanography. Okay, it's deal with, okay, the study of ocean condition, okay, and ocean processes, okay, using remote sensing. So kalau nak lagi accurate, it's a surface ocean condition, okay, and processes. Okay, sebab remote sensing ni dia tak boleh penetrate and deeper. Okay. So number 2 yang you have to know is about the major types of satellite oceanography. Okay, so kita dah belajar. They start from visible, okay, visible remote sensing. After that, we have infrared, okay, remote sensing. okay, for SST, visible for ocean color. And then we have a passive microwave to detect wind speed, and to detect sea surface temperature. And after that, we have number 5 and number 4 is a synthetic aperture radar. Okay, synthetic aperture radar. Number 5 is a scatterometer. Okay, scatterometer is an active radar. And lastly is altimeter. Okay. That one is the major types of satellite oceanography. Number 1 is a visible, number 2 is a infrared, number 3 is a passive microwave, number 4 is a synthetic aperture radar, number 5 is a scatterometer, and number 6 is a altimeter. Okay. So yang penting you tahu apa dia satellite oceanography. Okay. And then lecture 1, okay, is about electromagnetic radiation. Okay, so we learn about the passive, active remote sensing. Okay, we learn about the interaction of light with particles, okay, in the atmosphere. Okay, we learn about the atmospheric window. Okay, and then reflection. Okay, we have a diffuse specular reflection, and then we learn about the satellite. Yeah, polar orbiting satellite and geostationary satellite. Okay. And then the first one is what is an EMR? Electric, okay, magnetic, okay, magnet and radiation. Okay, so EMR is the energy, okay, from the sun that propagate, okay, through space and or material, okay, in a wave form. Okay, dalam bentuk wave. Okay, energy from the sun, okay, that propagates, okay, ataupun bergerak, okay, melalui space or vacuum, okay, or material in a wave form. EMR. And number 2, what are the major wavelength range used for remote sensing? Okay, so kita dah tahu dari major types. Okay, so the major wavelength range, okay, used for remote sensing. Okay, starting from visible, kita tak ada UV, UV, okay, ada setengah-setengah satellite, okay, specific satellite yang boleh yang pick up UV, tapi okay, the major wavelength, okay, visible, infrared, okay, infrared kita boleh bagi kepada dua, infrared and thermal infrared, okay, and microwave. Okay. Jadi 3 yang paling utama lah. Okay. So yang pertama visible, infrared, okay, and then number 3 is a microwave, okay, wavelength. Okay. And then you have to know about the wavelength range, okay, for each major wavelength. Okay, so describe the visible and infrared parts of the spectrum. Okay, so saya tak tanya pasal microwave. Microwave, okay, dia classification is based on the frequency. Okay, it's not based on the wavelength. Okay. So describe the visible and infrared parts of the spectrum. So for visible, okay, kita ada 3 yang utama, RGB, okay, red, green, blue. Okay, so visible, okay, range from 400 to 700 nanometer. So make sure, so bila you jawab nanti dia kena ada unit. So for visible, okay, it range from 400 to 700 nanometer or 0.4 to 0.7 micrometer. Okay, so visible is quite transparent, okay, to atmosphere. And then visible we can divide into 3 major wavelength or 3 regions, starting from blue. Okay, blue daripada 400 to 500, okay, or 0.4 to 0.5 micrometer. So after that we have green regions from 0.5 to 0.6 or 400 to 600 nanometer. And then lastly is a red, 0.6 to 0.7 or 600 to 700 nanometer. Okay. And for the infrared, okay, So, okay, it range from 0.7, okay, or 700, okay, to 1000 micrometer. Okay. So sama juga macam visible, okay, it's a very transparent to atmosphere. And then for the infrared, we can divide into 4 region. Okay, yang pertama kita ada near infrared. Okay, yang kedua kita ada shortwave infrared. And then after that, mid infrared. And lastly is a far infrared ataupun thermal infrared. Okay. So near infrared from 0.7 to 1.4 micrometer. Short infrared, okay, from 1.4 to 3, okay, micrometer. And after that, we have mid infrared, okay, from 3 to 8, okay, micrometer. And far infrared, okay, from 8 to 1000, okay, micrometer. And then what is a black body? Ini yang you dah baca, okay, dalam khusus ocean atmosphere. Earth and atmosphere. Okay. So why is a black body? Why? Okay, it's so important to satellite oceanography. Okay. So what is a black body? Black body is a physical body, okay, that absorb, okay, all radiation and emits all radiation. That's a black body. Okay, dia absorb semua radiasi dan juga dia akan emit, okay, ke semua radiasi. And the best example of black body is sun. Matahari. They absorb semua wavelength of radiasi, okay, radiation, and it emit back, okay, on radiation. Okay. So why is important? Okay, it's important, okay, because, okay, when we know about the black body, okay, we can determine the intensity, okay, and wavelength range, okay, of radiation, okay, that can be used, okay, by satellite sensor to measure, okay, the Earth's temperature. Okay. So kalau kita tahu black bodies, for example Earth, okay, so kita tahu dia punya temperature. So kita tahu daripada wind displacement law, okay, kita boleh calculate, okay, dia punya intensity. Kita boleh tahu juga dia punya, okay, the peak wavelength. Okay. So the Earth, okay, emit at far infrared, okay, lebih kurang 10, okay, micrometer. Okay. So daripada that knowledge, so kita boleh develop, okay, the sensor that can measure, okay, the EMR, okay, that is emitted from the Earth's surface. Okay, that's important of black body. Okay, black body. Okay, so kita boleh tahu dia punya intensity, kita boleh tahu dia punya wavelength range, okay, of the emitted radiation. Okay, so we can develop, okay, or we can determine, okay, what sensor or what wavelength, okay, is useful, okay, to be used to measure sea surface temperature. And then what then are the major types of atmospheric scattering and how are they classified? Okay, so atmospheric scattering dia ada 3 yang utama. Yang pertama adalah Rayleigh scattering, yang kedua adalah Mie scattering, dan juga yang ketiga kita ada non-selective scattering. Okay. So how are they classified? Okay, it's based on, okay, the diameter, okay, of particle. Okay, the diameter of particle, okay, as compared to the, okay, wavelength. Okay. So for the Rayleigh scattering, okay, so the diameter of particles, okay, or gases in the atmosphere, okay, must be smaller, okay, than wavelength. Okay, dia mesti lebih kecil daripada wavelength. Okay. So for Mie scattering, okay, the particles, okay, or gases in atmosphere, okay, is, okay, are equal or larger than wavelength. Okay, dia lebih besar ataupun lebih kurang sama. Okay, so untuk non-selective, okay, scattering, okay, so particle or gases, okay, must be, okay, much larger than wavelength. Okay, so, okay, kita classifykan dia berdasarkan, okay, size particle berbanding dengan, okay, panjang gelombang. And then what is a atmospheric window? Okay, how it is relevant to satellite oceanography. So what is an atmospheric window? Ada siapa boleh jawab? Yang faham, yang dah study untuk test? Maldin. Amirah, Mai, Ika, Anisha. What is an atmospheric window?
Doktor. Doktor.
Ya.
Saya rasa absorption by radiance of atmospheric gases, Doktor.
Atmospheric gases. So, bila kita sebagai atmospheric window, think jendela atmosphere, okay, we refer to the wavelength range, okay, wavelength range that is transparent, okay, to Earth's atmosphere. Maknanya yang boleh sampai ke muka bumi, okay, yang transparent. Okay, for example, is a visible. Okay, semua visible yang daripada matahari dia akan sampai, okay, ke permukaan bumi. Kita panggil sebagai transparent. Okay. That is an atmospheric window. Okay, so atmospheric window is a wavelength range that are transparent, okay, to Earth's atmosphere. Okay, so why, okay, and how is relevant to satellite oceanography? So, okay, so when we know about the atmospheric window, so we can determine the wavelength range that can be used by satellite sensor to detect, okay, the reflected or emitted radiation from the Earth's surface. Okay, so atmospheric window is a wavelength range that, okay, are transparent, okay, to atmospheric to Earth's atmosphere. And then differentiate specular from diffuse reflection. Kadang-kadang you tahu jawapan tapi nak explain tak apa. So differentiate specular, okay, specular from diffuse reflection. What is a specular? What is a diffuse reflection? Okay, so specular, okay, meaning that, okay, a single incoming light, okay, is reflected into a single, okay, outgoing direction, okay, due to the smoothness of the surface. Okay, so bila kita pakai specular, bermaksud bahawa, okay, a single incoming light, okay, is reflected into a single, okay, outgoing direction. Macam lampu sulur, okay, you sulur cermin, okay, a single incoming light, and then dia akan reflect into a single, okay, outgoing direction, okay, due to the smoothness, okay, of the surface. Okay, so diffuse reflection is a single incoming light, okay, is reflected in many direction, okay, in many directions due to the roughness of the surface. Okay, a single incoming light, okay, is reflected, okay, in many direction, okay, due to the roughness of the surface. Okay, there's a difference between specular and diffuse reflection. And then describe the advantages, disadvantages of polar orbiting and geostationary satellite. Okay. So, okay, what is a polar orbiting? Okay, what is a geostationary satellite? Okay, so kalau tu sebagai polar orbiting, that means, okay, it will overpass, okay, from pole to pole. Okay, polar orbiting. Kalau geostationary, okay, akan bergerak dengan pergerakan bumi. Okay. So polar orbiting, sebagai polar orbiting from pole to pole. Okay, so advantage dia apa? Dia cover, okay, the whole Earth surface. Okay, from pole to pole. And then high spatial resolution. Okay, so you boleh dapat dia dalam masa, okay, 1 hari, 2 hari. Okay. And then, okay, dia punya resolution juga, okay, is high because of low latitude. Okay, polar orbiting biasanya dia pada kedudukan lebih kurang 800 km. So you akan dapat high resolution. And then this advantage of polar orbiting is it needs precise orbiting altitude. So bila nak launch tu dia kena betul-betul pada satu altitude ketinggian. And then number 2, dia punya disadvantage is a short lifetime. Short lifetime. Biasanya 5 tahun, 6 tahun, kadang-kadang ada 2 tahun. Because of what? Because of atmospheric stress. Dia duduk di kawasan yang lebih rendah. So bila dia bergerak, dia akan ada wind stress. Wind stress yang menyebabkan akan ada stress pada sensor. So advantage dia cover the whole earth from pole to pole. High spatial resolution because of low altitude. This advantage during a launch. So you need a precise orbiting altitude kepada ketinggian yang betul, tepat. Yang kedua, dia punya lifetime dia is very short, because of atmospheric stress. So geostationary satellite, sebagai geostationary, so advantage dia adalah it cover large area because of high altitude. High altitude. And then high temporal coverage, dia boleh dapat sebab dia bergerak untuk sekitar bumi, dia boleh dapat setiap jam, setiap setengah jam. And then dia punya long lifespan, dia lebih lama sebab apa? Sebab di kawasan yang lebih tinggi dia tak ada stress, wind stress daripada atmosfer bumi. Disadvantage is a low spatial resolution. Sebab duduk di kedudukan yang lebih tinggi. So resolusi dia adalah lebih rendah. And number 3, the next advantage is dia tak cover pole lah, kawasan kutub. Poles are not covered. Itu adalah lecture 1. It's some introduction about remote sensing, physical properties of remote sensing. And then untuk lecture 2, so kita belajar sikit mengenai image processing. One is atmospheric correction and how it may affect the quality of the remote sensing product. So you kena tahu what is atmospheric correction, pembetulan atmosphere. So atmospheric correction is a process of removing atmospheric noises due to scattering and absorption of particle and gases on satellite image. So because of scattering, because of absorption, so dia akan ada banyak kita panggil sebagai disturbance yang ada dalam image. It's not from the earth surface, tetapi dia datang daripada particle and gases. So atmospheric correction is a process of removing atmospheric effects due to scattering and absorption by particles and gases in atmosphere. And then how it may affect the quality of remote sensing product. So kita tahu bahawa scattering due to particle or gases may result in underestimate or overestimate of satellite surface reflectance, especially dekat kawasan coastal area, and because of high absorption in the blue, so dia akan meningkatkan reflected in the blue. Kalau ada kawasan offshore water, low reflectance by atmospheric in the blue, so dia akan reduce blue reflectance. And then describe 2 main processes in the derivation of satellite ocean geophysical product. 2 main processes in the derivation of satellite ocean geophysical product. Sebagai contoh, kalau you nak calculate katakan chlorophyll, apa proses utama untuk yang derive chlorophyll from the reflectant. Okay. Yang pertama adalah to develop the algorithm. Okay. For example, the algorithm for Caulfield, the algorithm for SPM, the algorithm for primary productivity, and so on. Okay. So develop algorithm by examining the relationship between in situ concentration and reflectant. Okay. So bila satellite overpass, you collect katakan sampel air and then you collect juga reflectant at the surface and then you measure, for example, chlorophyll. Okay. And then you buat relationship ataupun regression between reflectant, sama ada yang you measure dekat ground ataupun you yang measure by satellite, and then you tengok dia punya relationship. Itu yang kita panggil sebagai algorithm ataupun model. So number one is a develop algorithm. Number two, you validate your algorithm. So you tak boleh sonok-sonok buat algorithm you sendiri, model you sendiri, and then you tak validate. Validate, you kena pakai independent dataset. You tak boleh pakai dataset yang you guna untuk develop. Sebagai contoh, you buat dalam kawasan you, tengok berapa orang yang langgar SOP, katakan 50%. So you tak boleh kata you punya model untuk predict yang langgar SOP 50% tanpa you validate. You validate, you tak boleh validate menggunakan objek yang sama ataupun orang yang sama, kamu kena cari orang lain. Betul tak 50%? So two main processes, one is a developing algorithm, number two is a validation of your algorithm. And then number three is the difference between level 2 and level 3. So ialah masuk dalam Ocean Color website, dia ada level 1, 1A, 1B, level 2, level 3, and so on. So what is the difference between level 2 and level 3? So level 2 is a daily image. It's a daily image. Level 2, derived from level 1, 1A or 1B. After applying sensor calibration, atmospheric correction, and the algorithm. After applying the algorithm, level 2. Level 2 ni dia adalah specifically for daily data. Daily data yang dia dah apply sensor calibration, dia apply atmospheric correction, yang dia dah apply model untuk particle. So level 3 is a geophysical data product for a certain period. So dia juga ada daily tetapi dalam resolution yang lebih rendah. For a certain period, daily, we have a weekly. Weekly, bila sebut sebagai weekly, dia bukan 7 hari, dia weekly biasanya 8 hari. So we have a monthly and we have seasonally. With low spatial resolution, 4,980 km and interpolated on a global scale. Ada setengah data, especially data-data yang derive data daripada produk yang lain, dia dah interpolate. So level 3 is a data product for a certain period, daily, weekly, monthly, seasonally, with reduced resolution. Dia dah ada 1 km, dia start ada 4 km, 9 km, 18 km. And also is already interpolate. Describe key processing stage, key processing stages to transform level 2 to level 3 data product. Processing stage untuk transform daripada level 2 ke level 3. Yang pertama sekali dia buat sensor calibration. Bila sebagai sensor calibration, dia buat match up between ground reflectant and sensor reflectant. And number 2 is atmospheric correction to remove atmospheric noise. Okay, number 3, the derivation of geophysical data product, okay, by algorithm, okay, and validation of the algorithm. Okay, yang pertama adalah sensor calibration. Okay, so kita buat sensor calibration. Okay, you ada in situ punya reflectant. Okay, you compare dengan satellite punya reflectant, and then you buat dia punya calibration dia. Okay, and then number 2, okay, kita buat atmospheric correction, remove particle, gases, okay, disturbance. Okay, number 3, okay, we derive the geophysical product by, okay, developing algorithm. And number 4, we calibrate and validated, okay, our algorithm. Okay, there are 4 key processing. Okay, sensor calibration, okay, atmospheric correction, okay, develop algorithms, okay, and then number 4 is, okay, validation. So ada apa-apa soalan tak? Okay, semua saya ingat ada dalam lecture note. Okay, tapi inilah key point, okay, yang you kena tahu lah. So lagipun online, you boleh buka lecture note pun walaupun tak digunakan kan. So key point yang you perlu tahu, okay, dalam setiap topik. Okay. So ada apa-apa soalan? Ada apa-apa soalan?
Tak ada lagi, Doktor. So
Tak
far.
ada lagi.
Tak ada, Doktor.
Okay, so lecture 3, infrared satellite oceanography. Okay, so dia punya key point, what is the brightness temperature? Suhu kecerahan. Okay, suhu kecerahan. What is the brightness temperature? Okay, so itu sebagai temperature. Okay, lepas tu disebut sebagai brightness temperature. Apa maksud? Sama dah temperature and brightness temperature. Okay. So brightness temperature is the temperature that would emit by a black body and measured as radian, okay, by the sensor. Okay, the temperature that would be emitted by a black body, okay, and measured as radian. Sebagai contoh, okay, infrared radiation. Okay, so we can convert infrared to sea surface temperature. Okay. Surface temperature. So, okay, radian tu kita kenal sebagai brightness temperature. Okay, so brightness temperature is the temperature that will be emitted by a black body, okay, and measured as radian, okay, by the sensor. Okay. So, why is SST usually measured at 3.7 and 10 micrometer? Kalau you buka modis SST, dia ada modis day and night, okay. So, dia ada 3.7 ataupun 4 micron dan juga 10 micron. Okay. So, why SST, okay, measured, okay, at 3.7 and 10? Okay, because these wavelengths, okay, are the most transparent. Okay. And then, okay, at 10 micrometer, so we know that our Earth is a black body, okay, with average temperature is about, okay, 15 degrees Celsius. So the Earth emit at, okay, far infrared, okay, or thermal infrared at 10 degree, at 10 micron. Okay, so because our Earth emit radiation at 10 micron, okay, so SST, okay, is measured at 10 micrometer. Okay, so yang ini yang paling transparent. Okay, sebab tu dia pakai 3.7 dan juga 10 micrometer. Okay, so why wavelength 3.7 cannot be used to measure SST during daytime? Okay, kenapa 3.7 micron, okay, tak boleh digunakan pada waktu siang? Okay, so we know that, okay, during daylight, okay, so we receive, okay, radiation from the sun. Okay, so walaupun dia peak dekat dengan green ataupun visible, tetapi, okay, banyak, okay, juga daripada infrared yang sampai ke muka bumi. Okay, so because of the the intensity of irradiance from the sun is nearly similar, okay, to the Earth's surface, okay, emittent, okay, to the Earth's surface emittent, okay. So it's a very difficult, okay, to separate, okay, the radiation. Okay. Sama ada dia datang daripada matahari ke ataupun dia datang daripada bumi. Okay. That's why 3.7 sebab dia lebih dekat dengan visible, okay, dan juga dia lebih banyak diterima oleh permukaan bumi. Okay. So it's a very difficult to differentiate, okay, which wavelength, okay, is emitted by, okay, the Earth surface. Okay. That's why dia tak guna pada waktu siang. Okay. Waktu malam is okay because dia tak ada cahaya matahari. Okay. And then differentiate between skin, subskin, and bulk temperature. Okay, what is a skin temperature? What is a bulk temperature? Skin temperature is a satellite measured temperature in the top few micron below the surface. Okay, that one is a skin temperature. Okay, a very few micron, okay, below the, okay, ocean surface. Subskin temperature, okay, satellite measured temperature in the top few millimeter, okay, below the ocean surface. Okay. And then bulk temperature yang you buat apa nama kerja lapangan, okay, tapi you tak ada kerja lapangan, kesian kat you. Okay, is a in situ measured temperature, okay, between 0.5 to 3 meter, okay, below the ocean surface. Okay, kita sebagai bulk temperature. And you ukur dekat lapangan secara in situ, okay, what's a bulk temperature. Skin temperature, okay, a few micrometer below, okay, the sea surface. Okay, subskin, a few, okay, okay, millimeter, okay, below the sea surface. And then, okay, what are the physical processes influence the skin temperature? Okay, so dia ada 3 yang utama. Okay, yang pertama adalah diurnal thermocline. Okay, diurnal thermocline. Number 2 is the thermal skin layer effects. Okay, pada waktu malam, pada waktu siang, because of the process of evaporation. Okay, so the heat will be transferred, okay, from the ocean surface to the atmosphere. And then kita ada juga because of oil spill, okay, surface film, okay, due to oil. Okay. So the physical process pertama adalah diurnal thermocline. Okay, number 2 is thermal skin effects, okay, because of the process of evaporation and condensation, okay, and also from winds, water polar mixing, and number 3, okay, because of oil, okay, surface film. Okay. So describe how diurnal thermocline influences the measurement of SST from satellite. So we know that sebagai diurnal tu adalah harian, okay, between day and night. Okay. So okay, especially during calm day, sunny calm day, waktu siang. Okay. So a diurnal thermocline, okay, a diurnal thermocline due to insolation, incoming solar radiation. Okay, incoming solar radiation, okay, dia akan increase the surface temperature. Okay, and then at night, okay, because of no insolation, incoming solar radiation, okay, so there is no thermal layer, okay, at the surface, so the surface would be, okay, cooler, okay, than measured at the daytime, okay, because of thermocline. Okay. And then describe how thermal skin layer may affect SST measurement. Okay, this is for thermal skin layer. Okay, it depends on the heat flux. Okay, heat flux from ocean to atmosphere due to condensation and evaporation. Okay, and during the day, okay, or night, weak heat flux. Okay, weak heat flux. Okay, we increase the difference between temperature, okay, at the skin and subskin layer, okay, during the calm day and night, waktu yang tak apa nama, without stronger wind, okay, weak wind, okay. So dia akan berlakunya apa nama yang kita panggil sebagai weak heat flux. Okay. Heat flux dia tak begitu kuat. Okay. So dia akan ada perbezaan di antara suhu di antara skin and subskin layer. Okay. So on windy day and night, okay, and because of very strong wind, okay, so strong heat flux, okay, will occur. So strong heat flux, okay, will reduce the difference, okay, of temperature between skin layer and subskin layer. Okay. So kalau angin, okay, bergerak lebih laju, proses evaporation dia akan berlaku lebih cepat. Okay. So evaporation is it's a cooling process, okay, for the surface. So suhu dekat permukaan dia akan jadi lebih sejuk. Okay. So dia akan ada apa nama big difference between subskin and skin layer. Okay. And then what are advantages and disadvantages of using infrared, okay, and microwave for SST measurement? Okay, apa beza, okay, ataupun advantage menggunakan infrared, okay, wavelength dan juga microwave wavelength untuk ukur apa nama SST. Okay. So kita tahu bahawa infrared SST, okay, is a very good, okay, because of, okay, it has a high accuracy, okay, pada pakai optical sensor, high accuracy, okay, and resolution, and can be directly related to SST. Okay. Kita boleh terus, okay, relate kepada SST. Okay. So infrared SST measure, okay, measure skin temperature. Okay, dia akan ukur skin temperature. Okay. So disadvantage of infrared, okay, dia ada impact daripada clouds, okay, and then dia memerlukan apa nama proses, okay, atmospheric correction process. Okay. Advantage dia high accuracy, okay, and resolution, high resolution, and we can directly directly relate to SST. And then infrared they measure skin layer, okay, ataupun skin temperature. Disadvantage is a cloud, especially in the tropics area. Okay. And then microwave SST advantage dia, okay, dia is not affected by clouds. Okay, so it easy to do atmospheric correction. Okay. Dan disadvantage, okay, adalah low accuracy, low resolution. Dan dia ukur subskin, okay, temperature. And then dia juga apa nama impact by, okay, apa nama ocean roughness and precipitation. Microwave dia sensitif kepada hujan. Okay. And then NIM-3 infrared satellite or sensor that are commonly used to study the ocean. Okay, ini yang kita tahu 3 infrared, okay, sensor ataupun satellite. Okay, yang pertama kita ada apa nama MODIS, okay, Aqua ataupun Terra. Okay, kita ada NOAA, AVHRR, okay, Advanced Very High, okay, Resolution, okay. And then kita ada TMI, TRMM, Tropical Rainfall Monitoring Mission, okay. And then apa nama microwave imager TMI, and then kita ada apa nama AMSR, Advanced Microwave, okay, radiometer. Kita ada ADIOS, okay, Advanced Earth Observing Satellite. Dia banyak lagi you boleh, okay, apa nama dapatkan daripada apa nama NOAA punya website. Tapi yang utama adalah NOAA. Okay, kita ada MODIS Aqua dan juga MODIS Terra. Okay. And then describe the spatial and seasonal pattern of SST in Southern South China Sea. Okay, so bila you belajar pasal satellite oceanography, you kena tahu dia punya pattern. Okay, especially untuk SST, Yang kedua adalah ocean color. Ocean color selalunya kita refer kepada chlorophyll concentration. So what is the spatial and seasonal pattern of SST in the southern South China Sea? So because of our region experience or characterized by the monsoon season, so we have a very clear season or very clear seasonal pattern during northeast monsoon and southwest monsoon. So we know that seasonal pattern of SST is controlled by monsoon season. So high SST during the inter-monsoon, during the inter-monsoon and southwest monsoon, high SST, inter-monsoon sama ada bulan 4, bulan 5, ataupun bulan 10, dan juga kita ada southwest monsoon, high SST, and then low SST during the northeast monsoon, bulan 11 hingga bulan 2, due to this sea surface cooling. During the inter dan juga southwest monsoon, high SST due to the sea surface warming. We receive more solar radiation during that time. So in terms of spatial, spatial pattern, so during inter and southwest monsoon, low SST in the coastal water, low SST in the coastal water, but during northeast monsoon, low SST in the offshore water. During inter and southwest monsoon, SST is lower in the coastal water, but during northeast monsoon, SST is lower in the offshore water. So ada beberapa soalan? Nak tanya selain daripada apa yang sebelah ini ke? Tak faham ke? Okay, so lecture yang keempat kita ada Ocean Optical Properties. Ocean Optical Properties ada beberapa point yang penting, tak banyak pun 1, 2, 3, 4, 5. The first one is you have to know about the remote sensing reflectant. Upwelling radiant, downwelling irradiant. Upwelling ni bermaksud bahawa dia bergerak naik ke atas. That means the reflected light or emitted light. So downwelling radiation ataupun downwelling irradiant, that is the light that coming from the sun. So explain how are they reflected. So kita tengok satu-satu. Define remote sensing reflected, RRS. Remote sensing reflected is the ratio between outwelling radiant and downwelling irradiant, ataupun the ratio between outgoing radiation, outgoing radiation is a radiant, and incoming solar radiation, or irradiant. Ataupun kita boleh kata sebagai the ratio between backscattered light and the sum of backscattered and absorbed light. RRS reflected sama dengan BB, backscattering divide by A plus B. So reflector ni you sama ada you boleh cerita ataupun define based on outwelling and downwelling radiation, or based on the absorption and backscattering. So what is outwelling radiant? Outwelling radiant, macam dalam nota, nak bagi the amount of incident flux, the amount of incident flux emitted, reflected, or transmitted on a surface, on a surface per unit area and per unit solid angle. So kalau outwelling radiant, jumlah cahaya sama ada yang sampai ke permukaan, yang di emit, yang di reflect ataupun yang di transmit, pass through object, on a surface area and a surface per unit area, per unit solid angle. So dia punya unit adalah watts per meter square per steradian. Watt per meter steradian. watts per meter square per steradian. Untuk outwelling radian, SR. And then downwelling irradiant, downwelling irradiant is the amount of incident flux, yang sampai ke permukaan, on a surface per unit area, on a surface per unit area. Unit dia watts per meter square. Kalau downwelling irradiant, dia tak ada solid angle. Dia watts per meter square saja. Kalau ada solid angle, itu yang dipanggil sebagai outwelling radiant. Kalau irradiant, watts per meter square. And then explain how are they related. So sebagai kita tahu, RRS is the ratio between outwelling radiant and downwelling irradiant. And then describe factors that influence the spectral reflectance. Factor that influence the spectral reflectance. So the first one is water types. There will be clear case 1, case 2, and number 2 is the amount of particle in the water columns. So boleh disebut sebagai particle, meaning that particle that can interact with light. So dia ada 3 yang utama. Kita ada phytoplankton, kita ada suspended particulate matter, and then kita ada organic matter. The amount of particle in the water column. Water types, the amount of particle in the water column, and then number 3 is the sun angle or incident angle of solar radiation. Waktu pagi lain, waktu tengah hari lain, waktu petang lain. And then number 4 is the ocean processes. Such as wind speed, that can mix the water column. So kalau katakan ocean is very rough, dia akan ada impact kepada remote sensing reflectant. Berbanding pada hari yang lebih calm, with wind. So factor ada 4 water types. Number 2 is the amount of particle in water column. Number 3 is the incident angle ataupun solar radiation, solar angle. Number 4 is ocean processes. And then describe apparent, AOP and IOP. Give example for each property. Apa dia AOP, apa dia IOP? Apparent optical properties, inherent optical properties. When we talk about AOP, means that the light properties, that's depend only on medium and geometric structure of the incoming light. Dia bergantung kepada particle, phytoplankton ke, suspended particulate matter ke, organic matter ke, yang pertama. Dia juga ada bergantung kepada incident angle. Ataupun kita panggil sebagai the geometric of reflectance. Pada waktu pagi, waktu petang, dan sebagainya. So contoh dia adalah remote sensing reflectant is a AOP, apparent optical properties. Kita ada water leaving radiant, and then kita ada KD, light attenuation coefficient is a AOP. So dia bergantung kepada jenis particle ataupun medium. Dia bergantung juga kepada the geometric structure of the light. Geometric structure, cara mana dia masuk, dan juga dia punya sudut, incident angle. And IOP, so kita sebutkan IOP, is a light properties that depends only on medium. Dia tak bergantung kepada the incident angle. Dia bergantung hanya kepada medium, types of medium. So example is absorption, backscattering, and attenuation, coefficient. So seharap you boleh beza dengan AOP. AOP is a light properties that depends on medium and the geometric structure of light. IOP is the light properties that depends on the medium. Contoh AOP is a RRS, remote sensing reflectant, and light attenuation coefficient, ataupun KD. So the example of IOP, absorption, backscattering, dan juga kita ada attenuation coefficient, ataupun kita nama sebagai C, attenuation coefficient. So define case 1 and case 2 water. So yang ni yang dibagi daripada first year sampai third year. You orang oceanography, marine science, you boleh tahu what is a case 1, what is a case 2. So nanti bila you minta kerja, especially dekat dengan jabatan yang melibatkan marine, dia akan tanya what is a case 1, what is a case 2. Dia akan tanya pasal El Nino, La Nina dan sebagainya. Yang bertanya tu bukan maksud dia tahu, tetapi dia pernah dengar pasal case 1, pasal case 2. Begitu juga pasal La Nina, impact El Nino dan sebagainya. So knowledge macam ni you kena tahu. So what is a case 1 and case 2? Why the open ocean is always considered as case 1, and coastal ocean is always considered as case 2 water. So case 1 disebut sebagai case 1, is kita sebut the water properties, or ataupun waters, whose optical properties are determined primarily by plankton, by its covariant product, ataupun covariant decay product such as SPM, suspended particulate matter, and dissolved organic matter. So case 1, optical properties determined primarily by phytoplankton and its decaying product. So bila disebut sebagai covariant ni bermaksud bahawa there is a correlation ataupun relationship between phytoplankton and its product, sama ada SPM ataupun SIDO. So kalau klorofil tinggi, secara automatik SPM juga akan tinggi. Dissolved organic matter juga akan tinggi. So bila disebut sebagai covariant bermaksud bahawa partikel tu dia derive daripada ataupun is a decay product from the phytoplankton. Especially dekat dengan offshore water, sebab tak ada sumber daripada terrestrial. So kebanyakan suspended particulate matter dan juga dissolved organic matter dia datang daripada phytoplankton. So kalau phytoplankton tinggi, suspended particulate matter juga tinggi, dissolved organic matter juga tinggi. So case 1 is the waters whose optical properties are determined by phytoplankton and its product. And case 2 water is a water which optical properties that are not only determined by phytoplankton, but also by other substance that do not co-vary with phytoplankton, such as suspended particulate matter and dissolved organic matter. So optical properties dia bukan saja determined by phytoplankton, tetapi juga ada substance that are not co-vary, yang tak co-vary, bermaksud bahawa that product dia bukan datang berasal daripada phytoplankton, dia datang daripada buah. So disebut sebagai case 2 water, kita refer kepada coastal water. Because of what? Because SPM and dissolved organic matter originated from the terrestrial, is a terrestrial inputs. Dia bukan datang daripada phytoplankton. Itu yang kita sebagai case 1 and case 2 water. Why the coastal? Why the open ocean? So why the open ocean? Kita consider as a case 1 water because open ocean is dominated by phytoplankton and its degradation product due to lack of other sources of SPM. Dia sebab dia jauh daripada land, so input dia bukan datang daripada land, dia datang daripada phytoplankton, and then area. Coastal water kita consider as a case 2 water, because of this water is dominated by substance other than phytoplankton, then originated from the terrestrial, daripada sungai dan sebagainya. And then relate AOP to IOP in case 1 and case 2 water. Okay? Relate, okay? You're going to relate AOP. AOP is, for example, it's like a reflectant, and IOP is absorption and backscattering. So we know that for case 1 water, okay, case 1 water, okay, sebab dekat kawasan coastal water, okay, partikel tinggi, so okay, scattering juga tinggi. Okay, so kita kena ambil kira, okay, backscattering. Okay, so case 1 BB over A, okay, case 2 BB over A plus B. Okay. And then lecture yang kelima, ocean color remote sensing. Okay, Alia, why why backscattering is more important than forward scattering? Okay. So, backscattering, kita sebut sebagai backscattering adalah cahaya yang direflect, okay, dan diterima oleh sensor. Okay. Kalau forward scattering, sensor tak terima, dia tak detect. Kalau kita measure pun, ukur pun, and then you cannot, compare ataupun you cannot mesh with the satellite sensor. Okay. That's why dalam remote sensing, forward scattering ni, okay, dia tak beri apa-apa makna. Sebab forward scattering ni, cahaya tu dia tak didetect oleh satellite sensor. Yang satellite sensor detect adalah daripada back scattering sahaja. Okay. Forward scattering yang bergerak ke bawah ke depan, okay, satellite sensor tak detect. Okay. So it's not significant. Okay. Okay, so what is ocean color? Okay. So ini yang paling mudah soalan dia, siapa boleh jawab? What is the ocean color? Siapa boleh jawab ini? Afiq, apa dia ocean color? Tak ada Afiq sini. Adam. Ada Adam. Ada juga. Tengok berdehan Afiq. Apa dia? What is the ocean color?
Ocean color yang di-reflect oleh ocean.
Color yang reflect oleh ocean. Okay. So Zahirah kata color of the ocean that indicate concentration. Okay. So semua tu betul lah. Okay. So bila disebut sebagai ocean color, okay, so we refer to the water living radiant. Okay. Water living radiant or reflected radiation, okay, in the visible. Okay. In the visible spectrum that give color, okay, to the ocean. Okay, that's ocean color. Ocean color ni bukan warna air biru, hijau, macam tu je. Okay. So it refers to the water living radiant or reflected radiation from the ocean surface in the visible spectrum. Okay, dalam apa nama spectrum visible, okay, that give color to the ocean. Okay. So describe the visible reflectant characteristic of clear and turbid water. Okay, visible reflectant, okay, in clear and turbid water. Okay. Oh sorry, describe the main in water constituent influencing the ocean color. Jadi ada tiga yang utama, okay, phytoplankton, pigments, okay. So we have a suspended particulate matter and dissolved organic matter atau colored dissolved matter. Okay, tiga utama. Okay, describe the visible reflectant characteristic of clear and turbid water. So clear water, okay, clear water, okay, so contain less particles, okay, so less absorption in the blue wavelength, okay, and low backscattering in the green wavelength, okay. So kalau clear water, okay, here's what, because of less particle means that, okay, less absorption, okay, sebab portion color ni kebanyakan particle dia absorb in the blue, okay, and then that scatter in the green, okay. So clear water because of less particle, okay, so it has less absorption, okay, in the blue and less scatter in the green, okay. So reflectant is high, okay, reflectant is high in the blue, okay, and low in the green and red, okay. Sebab daripada equation tu RRS sama dengan BB over A. Okay. Kalau absorption dia rendah, bermaksud reflectant dia tinggi. Okay. Kalau backscattering dia tinggi, bermaksud reflectant juga akan tinggi. Kalau backscattering rendah, okay, reflectant juga akan, okay, tapi because of reflectant is low, okay, but absorption is high, okay, so reflectant akan jadi lebih rendah. Okay. Tapi because of clear water, less particle, less absorption, okay, low backscattering, so reflectant is high in the blue, okay, but low, okay, in the green and red. Okay. In the turbid waters, because of high concentration of particles, okay, meaning that high absorption and high backscattering, so reflectant is low in the blue, okay, but high, okay, in the green and red. Okay, because of more particles, okay, particle seperti ocean color dia absorb, tapi dan juga dia reflect, okay, backscatter the green. Okay, so okay, the big waters, okay, so high absorption in the blue, okay, and high backscattering in the green, so reflectant, okay, is very low in the blue, okay, and high in the green and red. Okay. And then differentiate empirical, okay, from semi-analytical algorithms. So sebagai empirical ni is a very simple regression. Okay, kalau you ada x and y, and then you buat regression, okay, linear regression between x and y. Okay, so empirical kita boleh kata sebagai direct relationship, okay, direct relationship between in water constituents and remote sensing reflectant. Okay. So what's different, okay, with semi-analytical algorithm? Okay, semi-analytical is sebagai complex relationship, okay, between in water constituents, okay, IOP, okay, absorption and backscattering, and AOP, reflectance. Okay. So kalau empirical dia melibatkan concentration dan reflectance saja, okay. Tapi kalau semi-analytical melibatkan complex relationship between IOP, absorption, backscattering, okay, reflector and water ataupun and water constituents. Okay. And then describe the available types of ocean color product. Okay, so kalau you check dalam website this tu dia ada chlorophyll, dia ada sidon, dia ada reflector, dia ada particle carbon, dia ada particle carbon, okay, dia ada PAR dan sebagainya. Okay, and then name three ocean color satellite sensor. Okay, so we have a MODIS, Aqua-Terra, ada Seawave, ada CZCS, Coastal Zone Color Scanner, kita ada VRIS. Okay, so kalau kita buka dalam nama ocean color punya website, kan, dia bagi sensor. And then describe the spatial and temporal patterns of primary productivity. So ini yang kita tahu. Okay. Satu adalah SSP, yang kedua adalah primary productivity in terms of concentration. Okay. So sama juga case dia. Okay, so because of in the tropical region in our area, okay, we experience this seasonal monsoon. Okay, so the seasonal pattern of primary productivity is controlled by monsoon season. Okay, so low primary productivity or low crop concentration during the winter monsoon and southwest monsoon. Okay, due to the seasonal warming, okay, hibernation, high density, and high during the northeast monsoon due to the seasonal cooling. Okay, they receive more rainfall, okay, stronger wind in the northeast monsoon. Okay, so high primary productivity during the northeast monsoon season. Okay, so in terms of partial, okay, pattern, so primary productivity is higher, okay, in the coastal region, okay, due to the effect of the terrestrial, okay, influence, and low of the offshore. Okay, kita tahu kan about temporal pattern. Bila dia tinggi, bila dia rendah. Okay, so lecture 6 dan 7 tak banyak lah ya. Okay, describe the passive and active microwave processes. Okay, what is a passive and active microwave processes? Okay, so this is a passive. Passive meaning that receive method. Okay, or method microwave signal. Okay, yang dia reflect ataupun yang di emit. Okay, microwave signal. Okay, so that passive. Okay, kalau active microwave meaning that a sensor that transmit the microwave signal. Okay, microwave signal can enter the backscatter, okay, portion of the signal. Okay, they transmit microwave signal dan okay, dia terima balik, okay, backscatter signal. Okay, kalau passive dia tak emit, okay, dia own radiation for microwave signal. Okay. And then kalau kita sebagai active microwave, okay, so active microwave can divide by two, okay, imaging and non-imaging system. Okay, imaging yang dapat, okay, dia menjadi mesh biasa, okay, jadi ocean color dan sebagainya. Non-imaging dia pada bentuk intensity point sahaja. Okay. So bila you buat ada 5 itu, okay, so untuk wind speed and wind direction, so what is active microwave? Okay, you tak ada dapat untuk image, dia bagi bentuk point. Okay. And then sekali advantages and disadvantages of microwave process. Sama juga macam tadi, advantage dia adalah non-affected by cloud. Okay, so you will pakai all weather, okay, coverage, pagi, petang, siang, malam. Okay. Except during rain, hujan. Dia sebab microwave biasanya dia sensitif untuk hujan. Okay. And then dia punya signal is not affected by radiation. Okay. Dan juga microwave, okay, is very sensitive, okay, to surface roughness and water level. Okay. And then it's a subsurface penetration. That's why we can measure subskin layer. Okay, this advantage adalah low resolution. Okay, except for SAR, relative aperture. Okay, semua kecuali SAR, resolution is very low. Okay, and another disadvantage of microwave, okay, the data is a very difficult to interpret. Dia tak macam optical sensor dan motion color. Okay, dia tak banyak proses. Tetapi kalau untuk microwave, dia very complex. Dia banyak processing system. It's a very difficult to and then the next type of active microwave, okay, then type the passive microwave. Okay, the active microwave, passive microwave, especially the SSE, and then wind speed, direction, precipitation, okay, rainfall, okay, ice also, okay, the one for passive microwave. And for the active microwave, okay, is used to measure speed and vibration, okay, current, okay, is high, okay, wave high, okay, and okay. Okay, this is the basic concept of what are the main types of active microwave. Okay, what is the main type of active microwave? Okay, so active microwave is a thermometer. Okay, so we have a synthetic temperature radar, and then we have the RTD. Okay, the already specified cool down, poster radar, poster radar. They will detect the sensor. Okay, you got the so we have a schedule monitor, we have a synthetic temperature radar, we have a so this is the basic concept of okay. So what's the basic concept of radar? So the first point for the radar transmit this is known as high frequency. They transmit signal high frequency into the earth and receive an echo. If the movement is success, okay, so the travel time is measured. Okay, they must not come down of signal emission. Okay, the will right down. Okay. So that we have signal. So that we have measured. Okay. And then active or high, is measured based on the total of time. Okay, this is called blah. Okay, so the transmission yang masa dan juga yang apa namanya guru ataupun motor, okay, dari signal, okay, sampai pada sensor yang kami masa, okay. The high dia masa okay, speed of light, speed of light dia ataupun and what are the main application of radar activity? Can give example of sensor, okay. So radar ataupun main application of radar activity, sama seperti speed, social cover, direction, system high, if example of radar, the object is on kita ada listen and decide the course in sensor. So that was okay. So it was banyak. So ada apa soalan? So ada soalan tanya apa? Okay, ada why sensitive is more sensitive. Why sensitive is more sensitive so satu sensitive dia apa yang kedua basis ini depends on the reflected or tapi ini sensor dan ini pun dia pun signal that's why basis dia basis itu so ada soalan sebelum kita mulakan ada soalan Dia sama lah macam kalau ada kawasan kalau dia susu cahaya daripada torchlight very so cahaya dia akan follow in one direction dia akan follow in one direction and since rough sehingga cahaya dia akan dialihkan dia akan pantul ke different direction. So dia faham kalau dia rough, okay, so affected dengan light, okay, then will be move to in direction. So dia pastinya dia dalam satu direction ataupun dia semua cahaya ni detect sampai ke satellite sensor. That's why mana orang dia kita buat dia dalam sebab cahaya dalam sunlight ditambah lagi banyak communication. So kalau ada berapa dia banyak communication dia boleh buat transaksi dia langsung sampai ke satellite. So dia lain lah. So dah down ni. Dan you boleh bayangkan MCO boleh dan cuba menggunakan untuk buat sahaja 30% cases. 2 bulan daripada 2000 ke 14 so sekarang dia akan jauh ke 9,000 dia benar-benar buatkan ke macam-macam so kita memerlukan 8 bulan so kita ada 20 minggu buat kali sini sampai banyak. Satu lagi masalah ada yang sesi. Ada banyak first on the way we are down. Kadang-kadang banyak ya. Saya daripada bulan-bulan 2000 itu
sama lah kita.
macam dia dapat cepat.
Saya rasa bergantung pada kawasan tu.
Ya.
Dua-dua kawasan risiko tinggi.
Dengan usul sana. Dengan banyak customer buat kira-kira you boleh pendek semua dia ada nama 8 di dengan sampai terus. Okay.
Saya rasa buat kes-kes kritikal lah seperti ini.
Kalau kita dimudahkan okay, so kadang-kadang terus lagi Facebook bulan terus berkembang so you like mungkin ini dia pergi dari sini sangat untuk population selama 1.6 million dengan sampai dia akan so dia boleh bersama-sama. So the problem dengan vaksin, vaksin telah lahan, berkala vaksin pun sangat-sangat perlahan, kerjaan pun telah lahan, slow sangat. Sampai kadang-kadang tahun pun sampai kerjaan yang ada. Sebab lain macam Indonesia, Thailand, dia berkala vaksin komponen berbanyak so teman-teman terharap nak vaksin bila dibuat sekarang berusaha dia akan bermasalah. So orang mereka yang duduk di kampung dia tak kena sekali-sekali susah cari buat perjalanan. Why kita buat ini yang berkata kita masalah dalam vaksin dengan semua problem is keadaan jauh. So sebenarnya you boleh ada satu tempat yang tempat saja. Jadi ada penararan masing-masing betul-betul. So apa yang kerja salah rakyat membayar SOP pun buat pun banyaknya flow sekarang yang ini balik ketat seluruh baru so lagi point masalah kan yang jika ada vaksin dapat vaksin bagi guru kalau boleh ambil vaksin dan COVID so jadi situ ada sebab bila ambil vaksin dia bergantung kepada kategori yang dia banyak answer sebab kes dia masing-masing menggunakan sosok dia awal pada dia so ada vaksin tapi sekarang saya masih sibuk dapat tak tahu saya rasa kalau kes lagi
Online ke tu?
online so so saya agak tahu spesifik lagi keadaan so kalau dengan proses vaccination sekarang ini dia masih masuk awal lagi nak immunity kita proses immunity kalau asal-asalan sebelum kita proses akan dilakukan walaupun kali-kali saya sampai berlapan dan sembilan tapi dosis 8 aku dapat first so buat ngomong dulu kan di sini dia sama macam modal tahu sudah ada folio vaksin so folio masih ada vaksin ini so lagi lah. Sebab sekarang pun tengah work. Dia ada serem. So, dia tahu mana-mana satu orang yang begitu yang sensitif. Sebab kita tak ada. So, paling lagi pakai mask. Satu lagi dalam sekarang ni, you agak sokongan lain. Kadang-kadang keluar masa-masa dia agak postpone cik tentang mas sedangkan dia postpone dia lah banyak undang-undang dia ada politik efek. So dia agak asal daripada postpone datang. So sebab dia juga dia ada konten sebab so ada soalan sebelum saya stop di sini. Mostly dia beri Okay. Saya tahu orang dia positif dia ada rasa dia berbau dan kelas berbau sebenarnya yang jumlah positif adalah masalah untuk menjadi
Saya yang saya tahu kelas percobaan tak adalah kan yang boleh dia orang semua pergi orang ke follow lah. Tapi after yang ni yang positif yang boleh berlaya. Sebab saya salah mereka.
Kita
Kan kalau buang semua okey. Sebelum datang dengan yang berlaya tu orang ada je kawal. Tapi ada orang ni tak ada sampai lah sebalik berlaya yang balaya tu.
Saya ada masalah. Kita punya sosial okey, so yang mana satu dia buat test yang buat dia buat nanti. So problem di swab test dibuat. Dia tak ada pakai swab test. Kalau juga dia ni tak dia tak kalau mati banyak ada charge. So kalau diberi pergi ke hospital dekat free je. So mereka dia balik pada zon saya test. Free. So test problem. So dia nak apa.
Masih baik-baik je lah. Kita tak tahu apa jadi.
You must kita kontrol sendiri. Kita kontrol dia kita so the best is swab test. Swab test dia dia kalau ada masalah jam tapi misalnya apa ini memang cepat lah. Jadi ada so ada lagi semua. So kalau hanya agak ini dia kelas ni. So kalau dia salah ini boleh yang dengan kelas ini. So saya bantu kasih edukasi. So boleh lagi ingat saya dalam 5 itu tak lagi 4 yang saya rasa yang soalan soalan
Thank you, doktor.
Thank you, doktor.